mean, we started using everything in kind of a kitchen environment and using a lot of polymers that are used in the food industry as well, like alginates or PEG. And I think NES is one we yet used as latex, which is still kind of nature-based. And by adding certain other elements, we just can modify, for example, like the stiffness. This one is included sugar. The color is made by oxidation. So because there's a certain amount of vinegar in the liquid, if you put it on a metal sheet, it turns black. And depending on the time you keep it on, you get like more deep black or just like something greenish like this one. This one is just the natural color with like a waxy polymer inside. And this one, for example, is freeze-dried, so that the water is going out so fast that the fiber network can collapse. So you get like a really lightweight structure.
Wow.
Like it's super light.
It's almost like paper on body.
Yeah, it is it is cellulose.
Wow. Very good.
We're interested in the whole industry that could evolve, including or working with living organisms. So what we experienced so far is that it's much more like farming, or you have a time factor, the stuff is ripening. So if you start to look here, things happen inside, and by time like 9 to 10 days, the stuff turns, the mold turns white, and then you see it's ready to harvest. And then it's like a birth process. The stuff inside is warm because the bacteria create a certain heat, and the whole environment of production is totally different. And we are looking for the impact on society and ways to implicate it.
What's the name Selenium cones?
That's basically the name of the bacteria that we're using.
Ah, Selenium.
It's called Acetobacter xylenum.
And this is, I guess, done in Schwab Technical Institute?
No, this is my partner.
Oh,
so
I
these
see.
are our websites. So
Where-
we are collaborating with scientists that use this material for medical appliances. So the fibers are so pure that they can be implanted in the human body. And they make blood vessel implants from it, and like for heart surgeries, and they're currently testing on sheep and horses.
Fantastic. Very good.
If you like, you can touch the stuff.
Sorry.
I mean, people somehow are disgusted, but just because they know it's made from microorganisms, but basically it's nothing different than wet paper.
Yeah. This is being now.
This is
maturing?
basically what's inside there. No, we just took it out, and there's no bacteria left anymore. So it's
Wow,
really
like
like
skin.
yeah, it's really fleshy and.
It's amazing. It's really amazing. It's like artificial light.
Die Bakterien beschichten die Form von innen. Also wir lassen die Bakterien.
Und dann zieht das ab.
Ja, also das ist quasi.
You're going to have fun with that video.
So this is the shape we wanted them to go. So you really see everything. It's quite interesting.
Ja, es ist sehr lustig.
Wow. Things are moving faster than one can imagine.
Yeah, I mean we are really exploring everything on a low-tech base, but of course the potential, we see the potential in maybe not exactly using this bacteria, but you can modify so many factors that have an effect on how it's made and how the quality of the material turns out to be. Yeah.
Don't eat so. Ja, das ist
But I mean, if you start thinking about implication of some process like this, it's interesting to think about like a denorm for screws makes totally sense, but a denorm for potatoes doesn't make sense. So, in which boundaries do you want to have a material like that located? I mean, what are industrial standards and how do we have to think about new industrial standards that